All right. Welcome. Happy New Year, I guess. Welcome to 2026. Welcome to Going Meta, episode 4 in season 3. Hi, Jesus. How are you doing?
Hi, Alex. Happy New Year to you too. I'm doing great.
Thank
Yeah,
you.
it's good to be back. It's been a nice break, and yeah, all back fully energized and looking forward to this session and to many more this year.
Yeah, absolutely. It's always funny. I think when because of the cadence of Going Meta, it's always like one of the first things that happen in the year work-wise when you take a couple of days off over the holidays and New Year's, and it's like, where am I? What day is it? What am I doing again? So,
Exactly.
and I hope you all feel a little bit of that still in your mind. But coming back into it, I
I
think this is a
I
good
cannot
one
think
to start it.
I
Yeah,
cannot think of a better way to get back into kind of work motion than a
exactly.
going meta
Yeah,
session, right?
yeah.
Good.
Exactly. That's what I'm thinking as well. It's a great start of the year. I hope you all had a good time, a nice break if you had it. Otherwise, if you don't, then hope you had still a couple of good weeks in the past. Moving along, and I'm looking forward to this year. I'm looking forward to obviously kicking it off with you, Jesus. It's a great start, as you said, and it's going to be a couple of fun more episodes going forward, and an interesting year going forward with. And I wear this T-shirt on purpose. Notes. It still says 25, but well, it's going to be fine. But Notes AI happening in April, so that's going to be the first basic landmark in the year for us here. That is going to be a big event with lots of interesting sessions around AI and a Road to Notes workshop series leading up to it in March. So yeah, it's going to be good. It's going to be good.
Excellent. Yeah, no, I'm looking forward to that. I thought you were going to have some. Are we still in time for submissions for notes, or are we past that date? And I didn't know if we were going to make this
The
kind of
the
announcement.
date, the date has unfortunately passed
Oh,
just before Christmas. But if you have anything to share that is really good, ping me, preferably as soon as possible, and we might be able to do something. We can squeeze you in. Yolande, our colleague, is building the agenda, is reviewing everything and is setting everything together. So I can probably convince you to squeeze something in. If you have something that is groundbreaking, you think, okay, you have to have this in, then but don't come knocking in February, then it's going to be too
yeah.
late.
Well, yeah, you've heard it here. So if you have something really great, here's the man who can make a decision, right? But other than
Yes,
that, it's time for people to register for the event because it's
it's
coming
time.
up,
Yes,
and
yeah,
having it in our
yeah,
calendars is what we all need to do because it's going to be full of great content, I guess.
exactly. Yeah, yeah.
Amazing, good stuff. Okay,
Cool.
well, let's get started then, because we've come up with these. Well, you know how we like to listen to our to our audience, to our attendees, and has been one of the topics that keeps coming up. I mean, it's something that slightly outside of what we would normally cover, because we've been using ontologies like forever for all sorts of exercises, but we've not looked at them well from a construction methodology point of view. We sometimes say, hey, we're going to use this ontology. We often use Protégé, and we show it
Mm.
that's the schema that we're going to use to build a knowledge graph, or that's the schema that we're going to be using to drive the retrieval, or whatever the task is at hand. And we have plenty of examples of those, but we never focus on this is the process to build the ontology, or like what we're going to be doing today, these are ways to measure the quality of the ontology. And this is something that keeps being asked, and I thought it would be a good idea to spend some time looking at options around that. And we are not inventing anything here, so I've done a bit of research out there, and what we're going to do is take these ideas and put them in practice. So that's the plan for the session. Make sense?
Yeah, no, that's great, and it's also good to remind everybody, just if you have questions, if you have feedback, or if you have topic suggestions, then let us know, preferably in the YouTube comments. That's great, and like you said, these came up in comments, but also during live events in chat, and we have been asked about this a couple of times. So yeah, I think it's a good one to discuss a little bit with you all. If you have any feedback, if you have any thoughts yourself, if you have any, experiences, how you evaluate ontologies, how you deal with that, then let us know in chat, and we can obviously definitely include that in the discussion today, and see how it goes.
Good stuff. Okay, so as always, let's start with a couple of slides. I mean, in this case, I'm going to be jumping from the deck to the to our Aura environment, or to the different tools that we're going to be using. But yeah, like I was saying before, I've been looking a little bit at the literature out there, and some of the. It's true that we like to do hands-on stuff, so we are focusing a lot more on the measuring, on the metrics. How do I run something that tells me how good or how bad my ontology is, rather than spending too much time on the methodologies. Like I said, this is a big space, and there's lots of literature around, because these evaluation, these metrics go hand in hand with the methodology, right? So construction of ontologies is not different from any other kind of software artifact, right? So you kind of typically go into an iterative approach, and you evaluate the quality of what you produce, and you go on and on. So it's hard to detach the two. So what I've done is, do a little bit of analysis of the literature out there, and extract some common approaches to the evaluation of the quality of ontologies. And these are 4 areas that have surfaced. And let's go over each one of them one by one.
And it so always depends a little bit what's the desired outcome, right? I mean, you always have this it depends hanging over you, like a sentence nobody ever wants to say, but you have to say it more often than you want to, because it is really depending on all kinds of metrics. And yeah, we'll show a couple, and then maybe a mix of those is the one that makes sense for you when you build something or when you use it. So keep that in mind. That is always flexibility there.
Absolutely. But it's great that you mentioned that, because I think it's worth talking about the kind of ontologies that we are seeing in the field. And we've, again, used them several times in the sessions, up to this one over the last couple of years. So there's 2 main types, and I'm sure you'll remember these 2 large, sort of groups, types of ontology. I mean, there's many ways of classifying ontologies, but from a purpose or way of using them point of view, we see 2 types. I mean, one are these domain ontologies that kind of describe your area of interest, the domain that your graph is covering, and that are somehow an enriched schema of your graph, right? So this is the case when we do knowledge graph construction out of structured or unstructured data. What we give is a collection of the entities and the properties that these entities have, the relationships between them, so that we can map these ontology to the source systems, to the tables, to the CSV files. We've done that. I mean, you can look at many of the episodes. It also works when you're doing entity extraction from unstructured data, and we spend loads of time on that as well. So these are one type of ontology, and this ontology, like I said, describes your domain of an enriched schema, because it comes with a number of actions, and we've used it as kind of a guide to both build a graph, but also then we've seen how it's useful to have it driving retrieval as well, right? Because it describes what the information is in your graph. So that's one type of ontology. And what you will see with those, and that's, you can think of them as the sort of semantic layer on top of your data. These are, I wouldn't call them small, but they're smaller in size, in number of entities. And they're probably richer in terms of the types of relationships that they describe. Then at the other side of the spectrum, because it's just these 2 types, they're the large taxonomies. For example, you might remember when we did the ontology reconciliation, and we were looking at, I think it was the mesh terminology, then there was the disease ontology, and then there was some kind of SNOMED data. I can't remember. Some life sciences data from Wikidata or some other sources. And those were, and we've seen many of those were like large taxonomies. They would have thousands, sometimes even millions of entities or categories, typically organized in taxonomies. So there's not so much richness in terms of the relationships that connect them, but it's more kind of a hierarchical representation. The way you use those is to annotate sources. So you have many of our customers do that, for example, in scientific research. So you have papers and you want to extract terms of things that are mentioned. That can be conditions, that can be genes, that can be anything like and you want to link them to a well-defined terminology, if you want. That's part of one of these standard vocabularies organized in a taxonomy. So this is less of a schema. It's more a rich taxonomy that you would use for annotation. So these are the two large groups, and like I say, we've used them for different purposes, the two types. But today we're going to be focusing more on the first one. So we're looking more at the kind of quality of type number one. Does that make sense? I mean, it kind of aligns with what we've seen, right, Alex?
Yeah, exactly. It does align with that, and I think it's great, and it should be very interesting. And yeah, it's important to make the differentiation and make yourself aware of, okay, you have this more in-depth look at it, or you have more of a standardization entity kind mapping or matching ontology, and then you apply that and you look into that. And I think it should be interesting to look into the two ways and to make it fit. Yeah.
Actually, the metrics that we're going to be looking at today probably fit more the first category. But and again, keep in mind that this is kind of our own, how would I call it, like empiric sort of classification. I mean, it's probably the way in which ontologies are used in our space. If you look, of course, in literature, that you would find classifications according to many other dimensions, like upper ontologies, domain ontologies, or ontologies by the expressivity, how, whether they are SCOS taxonomies or RDFS or OWL. So there's many ways to classify, but this is kind of broadly a way of basically describing how we're seeing ontologies in use, rather than going into detail of what their internals are.
Exactly, and I think that's an important point, is that we're looking at this from a user's perspective, from what we have experienced from our users, and where we can classify those, and where we see that they are being used and they are being applied. And obviously there are probably, like you just mentioned, dozens of others that are more theoretically, maybe more academia background, and then they have their use as well, but not. But we have to narrow it down somehow, and we have to give it a playing field here. And if yours is not in there, so sorry, but we'd like to give a little bit of a classification overview here, and try to make at least of the more commonly used ones in that, if that makes sense.
Absolutely. Okay, so let's go into these four categories of metrics or evaluation areas for ontologies, and I'll talk very briefly through each one of them, and then we'll go and get our hands dirty and look at them in action. So there's the first category of structural metrics, and we've done that in many other contexts, but one way of evaluating the quality of an ontology is by looking at an ontology. Of course, as we know, is a formal description of a domain, and therefore is something that we can analyze, we can query, we can bring into Neo4j, we can programmatically make sense of, and we can do many things like we've done in the past. But one of the things that we can do is we can analyze them structurally, and what that means is we can say for every class, for every category in your ontology, we can go and look at, how many ancestors does it have? How many relationships, incoming and outgoing, does it have? How many, is it an orphan class? How many orphan classes are in there? So are there other wrong things like cycles or loops in your taxonomy? That would be a wrong thing. So there's a number of things that you can measure by looking for patterns, looking for shapes in your ontology. And there's a collection of metrics that look at the structural nature of your ontology. That's the first. The second one is an ontology is built for a particular purpose. I mean, we love ontologies for many reasons, but the best ontologies are the ones that are used and that solve problems and that help you do things. So ontologies typically match some requirements, and that brings me back to, I think it's a couple of sessions ago when we used the MCP modeling server with Alex Gilmer, remember, right? Where we used that server to help us, to be our assistant, to create our ontology. And it started from what? It started from some source data, but it started from a collection of competency questions, from a list of what do I want my ontology, my model to answer. And I said, well, in that case, remember, it was the one about the London plaques. So I wanted to say, I want to understand who lived at this address and what was their artistic activity, things like that. So you had a collection of natural language questions, which is what we call these competency questions. And we need to make sure that these questions are reflected in the ontology. And the ontology is, probably expressive enough is not the word, but it covers the required domain to answer your questions. And if not, we should be able to, what's the level of coverage that we have? This is, again, something that we looked at when we did, tangentially, when we did remember, we looked at doing dynamic ontology selection, right? When we were trying to we've seen how when we build the knowledge graph from unstructured data, we use an ontology to drive the extraction. Sometimes our users say, hey, but I don't know upfront what I want to build a system that's flexible enough to, given any random document, you go and pick the right ontology. So what do? Well, you analyze the document, you try to do some form of similarity. Is there an overlap with some existing ontologies? And we determined, yes, based on that, this is an ontology about sports, remember? And there was another one about books. And we were able to based on these overlap, to pick the right ontology. So that's similar ideas. So we need to, given the questions that we have for our domain, is our ontology, again, I was going to use the term expressive. It's not expressive, but does it cover the right domain to answer those questions? So that's the second area, right? So does it fit the requirements? Does it match the competency question? And if not, what's the level of coverage? So that would be the second kind of way of measuring the quality of your ontology. The third one is more pragmatic, right? How easy is it to use your ontology? So is it well annotated? Does it have good descriptions? Is it public? Is it discoverable? Can I dereference it on the? I put the web usability, because some of these metrics, as you know, ontologies have been around for quite a while, and they're, in the early days, they were associated with the semantic web, and a lot of the usage was around linked data and data on the web. So, but in general, this category of metrics is how easy it is to use this ontology, right? Which I love, by the way, because the best ontology, like we've said, is the one that's used. And if you don't make it usable, you better provide good descriptions with good discoverability, etc., etc. And finally, there's a fourth category, which is it logically sound? In ontologies, we can enrich the domain description, the categories, the relationships, the properties, with additional axioms. Axioms, there's many of them. There's domain and range when we define a property. There's subclass of when we define hierarchies. But there's additional ones. And when we introduce axioms, these are logical statements, we can introduce inconsistencies. So being able to detect these kind of inconsistencies when we use these more advanced, this is probably for a reduced subset of our users, but when you use this type of constructs, there's also mechanisms to detect, hey, what you've done includes an inconsistency, so you better fix that.
Yeah.
So these are the four categories. Does that make sense?
Yeah.
Should we go and look at each one of them?
Yeah, let's have a look. I think what's always something to keep in mind here is if you think about this, don't make it, and if you start out with this, don't try to make it too complicated, because that's something that easily happens. And I know you start out with something, you draw out a model on your white paper, you use ontologies, and then you go that all, and then all of a sudden you have a super complicated model because you think it's the way it has to be. And if you take a step back, it can be very easy and can be brought down to a couple of easy structural, and it's like the ease of use. It's very important here to not overcomplicate it, because you can, anything can be complicated. The beauty is if you take it away and bring it down to a model that's still working, and includes everything, but is not overly complicated or doesn't have these, like you said, and dead ends, loops, and all of this stuff, because you think it has to have it, because when you think about it in the first place, it makes sense. But when you think about it again, you can do without, probably.
That's totally right. And again, another thing that's super important, and I said at the beginning, is we're going to formalize these metrics, and we're going to track them as well, we're not going to do all that today, but I'm going to show how to formalize these and how to build these into your ontology life cycle. Because like you were saying, ontologies will evolve over time, but we need to introduce instrumentation around it. So I need to be able to measure quantitatively, and it will be, I mean, I'll provide some metrics here, but of course everyone will be able to extend it with their preferred ones, or the ones that make sense in their domains. But very, very important, make data-driven decisions. So quantify the quality and see how it evolves as your ontology changes over time. Only by doing that, you're going to be able to do not just gut feeling, but really informed decisions. And you're going to be able to detect and understand, hey, there's been a degradation in the quality of my ontology by introducing that change, or there's been an improvement. So being able to formalize that, and that's something that we've done many times. I think last session, we provided a collection of questions, of queries that evaluated the quality of the extracted data. So one thing is saying, this is good, this is bad. Another thing is having a collection of 20 queries and seeing how many pass and how many fail. So that we want that. So we're totally in favor of this kind of more rigorous approach and quantifiable and measurable approach to evaluating these kind of things. So that's important. So cool. Okay, let's get started. So what I'm going to do is, sorry, did I interrupt you, Alex?
No, I was just saying that. Yeah, let's go.
Good. Yep. Good. So I have some examples for each one of them, and what I'll do, because this could be not one session but a whole course on multiple days on the topic. So what I'll do is provide references to where does that come from, and I leave it to the interested reader or attendee to go and dig deeper. So let's start with some structural metrics. And this first one it's what's called class connectivity coverage. Again, this is not me defining it. You have the source here. This is, excuse me, the DKE quality inspection methodology that's defined in this article, an ontology knowledge inspection methodology, blah, blah, blah. So you have the link there. Well, you have it, Alex. We might need to extract the link and put it. We'll do that afterwards. But
yeah, we'll put it in the YouTube. You have the as always.
The paper. We can add it at the end in the last slide. But basically what this measures, and I'm taking that from this article, and I apologize. These articles sometimes refer to each other, so I might be putting this metric associated with this article, but maybe this article refers to another one. So this is not meant to be super strict, but more like a way of giving you pointers to go and find more detail about it. So the idea of this class connectivity coverage is we have classes in our ontology, and we need to understand which fraction of the classes are connected to other classes. And the way we connect classes is through relationships. Relationships are object properties in ontologies, and whether they are incoming or outgoing, whether they are domain or range, we can identify when a class is connected and when it's not. And the way this class connectivity coverage is defined is the sum of connected classes, connected through object properties, versus the total of classes. So that's pretty much it. And then they define a metric score. So if this number or this ratio is in any and some particular ranges, they provide some metrics. So these metrics can be combined, and there's different approaches. This is the DKE methodology, but there's others. But how can we implement that? So I'm going to jump here to our example. So I have, as always, an instance of, hang on, let's do things right. Shall I make it a bit bigger so that we take all the state? I hope it's big enough. So this is an empty Aura instance, and I have created I think I had, I have it here, sorry. I have a notebook. Apologies. Oops. Here we go. Okay, and I'm going to use the notebook to take an ontology and then populate into my Neo4j instance and then do this kind of analysis. So this is a fragment of code that you might have seen before. I'm using this open source library called rdflib Neo4j, which we've talked about in the past. Is an extension of rdflib, which is probably the most popular Python library for managing RDF. And it helps us connecting to Neo4j and importing any RDF data. So I'm going to take one ontology, and I'm going to start with one that we used in episode 15. Let's copy the URL so you might remember this one. I'm going to, oh, I have it here. Here we go. So this is, I can't even remember what we did on episode 15. But anyway, we created an ontology that was a movies ontology. It's, as always, is an OWL. This probably is a couple of years old, but anyway, it's an OWL ontology serialized as turtle, and it defines, well, the usual movie domain. So there's if we look at let's look at the classes at the bottom. So we have actors, artists, critics, directors, we have movies, we have performing artists, we have a kind of a taxonomy. We're gonna look at that in more detail once we import it. But well, we have a rich collection taxonomy of classes. We have some attributes like the title of a movie, the tagline, the name, the date of birth, etc., for actors, and so on and so forth. Anyway, it's one ontology like any other. And what we're going to do is we're going to load that into Neo4j. And we do that very easily with this fragment of code. So I don't know if I've run it before, but we need to import the rdflib Neo4j, which will bring the dependencies Neo4j and rdflib. Then I'm going to do some imports, and I'll run this code. And while it runs, I'll explain what happens. So basically here we're providing the credentials.
Just briefly, as always, these notebooks and the code snippets will be available in our GitHub repo.
Absolutely.
So if you check out later this week, you'll go and see all the bits there for you to replicate.
Absolutely. So that's that will be checked in just after the session. So I was saying that we have the credentials, the authentication data, like the URI of the database, the user and the password, and there's a simple command.
And maybe
so we
can you zoom in a little bit?
Oh, bigger?
Here, a little bit bigger here in this. Yeah, I think that's better.
Is this better?
Yeah, okay. Let us know if you need it larger, but I think that this should be helpful. Yeah.
So here I'm defining the default namespace, but basically I'm just defining a store. Store is kind of an abstraction in the rdflib library, and I'm specifying the authentication, the credentials that I created, the prefixes that I'm going to be using, etc., and some choices in terms of how do I won't spend too much time on that. There's sessions on how to use rdflib Neo4j, but I'm pretty much stating how I want these RDF data to be imported. And all I need to do is create a graph with that store and just parse the ontology. I'm passing the URL of the ontology that I just shared. Please remember, if you do it at home, that this is not the URL to use. You have to go and use the raw one, because if you pass that, this is the HTML of the page that you're passing. So you want to go to the raw format, and this is the actual raw ontology. So this is the URL that you want to pass to the library for the import. And if you do that, specifying the format, which is turtle, you will import. It's a pretty simple ontology, 131 triples, but we should have it loaded here in Aura. Here we go. So that's a quick operation, and we can do things like, okay, let's find and run a query. Or will I? Yeah, why not? Let's see the taxonomy, which is one of the most interesting part. I'm going to tune a little bit. Let's make these a bit bigger, as always. We can get rid of that. So I don't know if that's readable, but can we apply hierarchical layout? I love it. Brilliant. So that's
nice.
So well, basically you see that. Can I invert it? No, that's too much. Well, anyway, that doesn't matter. So what you see, I hope that's if not not too readable, but anyway. So we have a person. Oh shit! I didn't want to do that. Sorry. And expand. Here we go. Because I wanted to focus just on the taxonomy. So we see the subclass of relationship, and for each one of the items we have at the root we have person, right? It's a multilingual I can't remember what did we do with that, but it was one where we're using multiple languages for the ontology. So we have the notion of person, persona in Espanol, and all that, French. And under person, we have things like, what is that? This is a supervisor. This is a professional. This is a critic. This is an artist. Under artist, we have performing artist. Under performing artist, we have actors, well, and so on and so forth. Anyway, so we have the ontology loaded. I wanted just to show a little bit of the taxonomy part, but it's already loaded here. And the reason why we've loaded is because we wanted to run the metric that we described, right? This class connectivity coverage. And what I've done is created an implementation of this that you have already in the repository. This I've checked in earlier today. And you see how this class connectivity coverage is represented in a simple Cypher query. So I can copy this and I can run it. And let's analyze it in a minute. But I get this metric. And I've created actually two versions of it. And you will see in the papers, and you as in you, our listener, if you go and look, that sometimes these metrics are defined, they're not implemented. So they're described, and so there's different interpretations of the definition. I've tried to be as accurate as possible, but this one, if you remember, it was something like, I want to understand how many classes participate in a relationship, right? Either incoming or outgoing. So the easiest way to do that is, okay, I count for every class the number of incoming or outgoing, so either domain first or range first, but anything that connects me to another class. But then I said, okay, that's interesting, but what if I am a subclass? Let's say I am there's a relationships that's defined for a person, and I'm an actor. As a subclass of a person, I kind of also use that relationship, right, through inheritance. So I don't know, that might be me being a bit picky, but I thought maybe we want to consider that as well. So I created two metrics, connected count and connected count extended, which includes this taxonomical expansion, right? So effectively, the first one will give us that every class would have 1.6 index of connectivity. But if we take into account the kind of inheritance type subclass of transitive exploration expansion, we get a higher metric. So all this to say that these are metrics and mean what they mean, and you have to pick the ones that are relevant to you. But the moment you have them, it's a question of, okay, I now have formalized them in a query, and I have them here for the first one. And what I would suggest is, well, let's have them built into my pipeline. So every time the ontology evolves, I would load it into the graph and have this complete set of metrics rerun again. I'll show.
And then you can compare basically what's changed and.
Exactly. That's exactly the idea. I will not spend too much time, but there's 2 or 3 more. So there's another one is property richness, which is again described in another article that I refer to here. It's OQuare, which is a framework to evaluate ontology quality, and they define again another collection of metrics, and they define this property richness ontology, which is the number of properties divided by the number of relationships, which is, to me, it sounds a bit strange. I don't know how, globally the number of properties divided by relationship, but anyway, that's one metrics that's defined there, and I've implemented them in Cypher. That's this one here, I believe. Now, the thing with this one is that if you look at it in isolation, it misses one important point, at least to me, right? So this is property richness, that's the count. So basically, this is the property count, this is the relationship count, and this is the ratio, 42%. So this in percentage is 0.2, which is the result of dividing 6 by 8. Now, yes, that might be one metric, but I think it would be even more interesting if we look at this metric at the class level. So for each class, what's the ratio between the properties and the relationships? And that's why I was being creative here, and I call it JB's variant, which is class-centric. And what I do here is I do exactly the same thing, but I do it at the class level. And in this case, I get a much lower metric. Instead of 42%, I get 21%. But what I'm getting is for each class, and I can probably show you, all this code is available, so don't worry if I do some changes here. So what I'm doing is for each of the classes, and we have the URI identifying each of the classes. So for actor, we have no properties, because probably the properties are defined upstream in probably a person or something like that. But we have one relationship. So in this case, the local, the individual, what was it called? The property richness metric would be 0, because it's 0 divided by 1. But like this. So there's many ways to look at it, and maybe we can aggregate those and then compute the metric. So I would totally invite you to not follow these religiously, but probably get inspired by them, understand what's the meaning behind. So and in the article you will find why this makes sense, and in that particular context. It's interesting because for this particular methodology, the OQuer, there's another paper that kind of evaluates the methodology itself and evaluates the metrics and says in which case the metrics are good, they're bad, they're incomplete, etc., etc. So this is not like a rigid approach. So there's things that have been used there, and that can be probably inspiration for you to take them and use them and adapt them to your problem. So what I've done again is implement a couple of other. So there's lack of cohesion in methods, and that's the definition. I don't think it's worth me going one by one, because you have them in the deck here. There's coupling between objects, CBO onto, and here's the definition. And again, for each one of them, you will find them implemented. So we have the CBO, and I think the other one was the lack of cohesion, the LCO. So these are queries that you can go run and get the metrics, so you can get the each one of them. In some cases, I've again created my own variant because I thought it was meaningful to, for example, in the CBO onto, which is related to the first one, the coupling, it looks at how connected classes are, but just looks at direct ancestors, direct parents. And I say, well, hey, connectedness is not just about taxonomy. It's also the relationship that we're looking at before. So maybe you want to extend that definition, not only with the taxonomical relationship with the subclass of, but including also the non-taxonomical relationships. And that's where I included, the others. So anyway, I hope these give you more an inspiration than anything else to come up with metrics that will give you an idea of what is the structural shape of your ontology. So that would be the basic CB onto looking only at taxonomical. This is a taxonomical plus a domain and range, and this one will be including the inherited ones. So different metrics for different things. Now, you might be thinking, Alex, well, all these queries look great, but I would put all those in a dashboard, and like this, I would have a nice overview. And it's a great idea, because that's exactly what I was. So we have dashboards.
Great idea.
And I'm going to import one that I created before, and basically, which I'll also make part of the repository. And what we have is, don't judge me on the style because it's a bit ugly, but it basically contains the metrics that we're looking at before. So the class connectivity coverage that we looked at. So for each one of the classes, we have it here, right? So we can see that, I don't know, for example, in this case, there's a big difference between the connected count and the connected extended one that I described, not only with the taxonomical, but also with the rest of the rest of relationships. The ones that were global aggregates, remember the PR onto was the one that again counted only the taxonomical, and the taxonomical plus the others. So you can have a dashboard with all the metrics, and that keep track of changes. Well, in this case, that gives you a snapshot of what your current ontology is. If you want to keep track of changes, you would need to that's probably an interesting exercise for another episode. Maybe keep versions of the ontology and track how these metrics evolve as you change. But this gives you an overview, and each one, for those of you who have not used dashboards before, each one of these, if you edit it, it basically is backed by the query that I showed you before, right? So all you have to do is populate it with the query that you want to run, choose the style. I picked a bar chart, but you can use a line chart. You can define the title. You can put some settings in terms of, do I want it horizontal, vertical, blah, 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 etc., etc. And when you're happy, you save it, and you have the widget there, and you have a nice kind of aggregated view of all these metrics in one single page. So there you go. So that's the first section, the structural ones, the first category. Although when we moved into the pragmatic ones, it's not very different. So one of the pragmatic metrics, and again, I keep using the reference to the articles with, I think this is one of the ones that we mentioned before. One of the pragmatist metrics is, is your ontology properly annotated? Does it come with labels and comments? Labels different from what we mean in InfoJ. Label is a type. Label in the RDF world is RDF label, which is basically a human readable name for the URI. So, but again, does it come with a human readable name? Is it easy to use? So that's another metric. Is similar in the way it's calculated, but it falls in the category of the pragmatists one. So if we run this query, we can go back to our database, and we can compute how many, which one was that? C would be the comment, the total count, the class count, and the annotated class count. In this case, it's pretty good because I've annotated every single one of them, so I have 100% coverage. So pretty good. But that's not always the case, and again, you might want to refine. Here, I'm taking, is there at least a comment or a label? Maybe you want to split it and have two different metrics, right? So I'm going to remove notifications so that we don't. So yeah. So that's the idea, and that's what we're looking at the. Was that a question? Sorry,
no,
Alex?
I was just thinking this is also great. A great I think this particularly one is great for the dashboard you showed earlier. So while you're building out your ontology, while you're building this you can use that as a tracker and have it as a guiding and say, okay, maybe I'm at 90% annotated because I'm just building it out, and I know, okay, these are the ones I still need to do. Maybe I have a couple of other metrics that need to I can track easily, and by using this dashboard as a great guide while building it. And as you said, mix and match a couple of those metrics that you think are most relevant to what you want to achieve, and then have a dashboard accordingly that kind of guides you a little bit and gives you where the gaps in your mapping.
I'd love for any of our listeners to go and make this nicer and better. I haven't played enough with dashboards, but I think you can have pages, so you can have like multiple tabs and do it a lot richer, give them titles and maybe structure in, and there's dynamic elements, so you can select things and have them behaving dynamically. So there's a lot that you can do. So yes, you're right. It's a great idea to build kind of a rich kind of point of access that gives you what your ontology looks like from the point of view of the quality. So yeah, that was the annotation. The other one was this one I've not implemented is another one that's they call dereferenceability. So an ideal scenario is where the ontology is public and discoverable, public in whatever your scope, whether it's public in the web or public in your organization, but it's reachable and accessible. And for every class or every element defined in the ontology, you can dereference and have some meaningful and relevant data about it, right? So these, in some cases, it's true that we don't typically publish them. Sometimes we've done, and I think in the past, I think we have a couple of published ontologies. Was it? I think we had. Yeah, I remember we had the clothing materials ontology. That's one that we used in the past for a recommendation system. So this will be a case where the ontology is public and is dereferenceable, but it's not always the case, right? So a way of measuring that, and which I did not implement, is just do an HTTP GET request on the IRIs as described in this article, and then return OK if it returns meaningful information or not. if it doesn't. So that would be another way of measuring the usability of the ontology. Another one, because I'm conscious of time and I want to cover them all. So this is particularly interesting, which is described. I'm particularly fond of this one because this is a chapter written by my PhD thesis director. So she published this article, this chapter 13 on ontology evaluation. So, and one of the ways in which she describes how to evaluate ontologies is by aligning them with competency questions list, right? So basically, these are the questions. That's the reason why I build my ontology. So does it cover the domain required to answer this question? And unfortunately, this is something that's very natural language process driven, right? So it's not something that we can do simply with the pattern matching expression like we've done in the others. And what I've done for this one is these days we have a perfect partner for that, which is LLMs, right? Yes. LLMs are brilliant at that. So if I go back to my notebook, which is here, you will see in the bottom section that I've written a very simple tester, and without going, I create a description of the output that I want to get because I want to be able to use it. But basically what I'm doing is prompting the system like this. So you're an ontology QA assistant, and I'm going to give you an OWL ontology as text and a list of competency questions. And what you have to do is judge how well the ontology could support answering each of the competency questions. And I want you to produce something like a 1 if the ontology clearly models the required properties, classes, etc., etc. 0.5 if it only does it partially, or 0 if it doesn't. So that's, of course, feel free to and if it doesn't, explain concisely and even provide some recommendations and some examples in Cypher. So
yeah, cool.
This is the format of the output. But if I run this quickly, and I'm going to run this on this simple ontology, I could run it on the other one, but I've created a simple one that has as you can see, has a person. A person has, in this case, has a mother is another class, not particularly good as an ontology, so don't judge me on this one. But I define the notion of mother, and they're connected through the has-parent relationship, and then there's has-child. So very simple one, but then I have a collection of questions, right? So, and they're simple questions like, can we retrieve all parents of a given person? Can we infer that the mother is also a person? And so on and so forth. And of course, I pass this list of questions and the ontology as text to my LLM. And keep in mind, we touched on this last time, LLM is not an inferencing engine, but it's going to explore the ontology, and it's going to try to match these two things and give us a report. Where I will enforce the structure is by providing this JSON description of what the format of my output should be. And I will get something like, here we go, something like this. So the overall score is 0.25, but the first question is 100%. So can we retrieve all parents of a person? Yes. And that's the way we would do it. So person has parent, we would return the name, and so on and so forth, right? So can we infer that the mother is a person? Yes, we can, etc., etc. And in some cases it will say partially. In some cases it will say no, it doesn't, right? So and I asked it to also provide some recommendations. If you want to cover that, you want to introduce another class or another type of relationship. So this is again prompting your LLM. So you want to build that according to your case. But it's pretty straightforward collection of questions. If you use the approach that we took in a couple of episodes ago, because the competency questions are built into the ontology construction, you would expect that the coverage is close to 100. But you don't always create ontologies using the modeling MCP server, so it can, an ontology can evolve over time and new requirements may come. So anyway, that's a potential implementation that I'll share also in this format.
And I think that's a great thing if you already have a ontology built or something that you use, and then this is a great way of saying, okay, this is the structure I have. what needs to happen to cover questions X, Y, or Z, and how do I do it? And then I think with a, you can do it and you can think a little bit about it, but you might miss some bits here or there, like this loop with an AI could be a good one to make sure that there's no gaps.
Absolutely. And I we're looking at these kind of in isolation as fragments, but I love the idea of building these into your process, into your methodology, right? So we would iterate, we would run the metrics, we would, get, the result of every change, and all these batch of metrics would be run every time there's a change.
Yeah.
And then, well, with that, we go into the last one, which is probably the more sophisticated one, which is the logical soundness. So sometimes when you use certain types of constraints and certain types of artifacts in your ontology, you might get into situations where you introduce inconsistencies. And, well, if you have a reasoning engine, in this case, I would totally delegate that to a reasoner and have it surface the unsatisfiable classes. I'm going to show you a simple example. We've used Protégé many times here. So I'm going to show you what that looks like, because sometimes we refer to it and it might sound something pretty sophisticated, and it's not. So, this is Protégé. You're familiar with it, so we've looked at it many times.
We don't see it yet, Jesus.
You don't?
Wrong screen, maybe.
What is that?
We only see the browser. Maybe it's...
How is that?
I think you share only a window and not a screen. Is that it?
Oh, that's possible. Let me give you a try. Sorry about that.
No problem.
So an entire screen. There we go. So you should see my browser and now my project.
Yes.
Is that it?
Yes.
Perfect. So so I was going to say that you can, you can open ontologies from a URL, and if you go on that option, there's a bunch of them that come built in, and they're typically for educational purposes. But there's this one about koalas, and I'm going to open this one. So it's a pretty simple one. And if we go to the classes, we'll see that it has a taxonomy, like we've built many times, that defines animals, and you have marsupials, of which a koala is a type. And then there's the notion of a koala with a PhD, which is an interesting concept. And we also have persons, and we have students. Anyway, that might not be super. Can I make this bigger? Let me try. Oh, it's not letting me.
I zoomed in a little bit as well. I think it's okay.
Well, if you can, though. But basically, I won't go too much into the details. But for example, in this case, you define a taxonomy where a koala is a type of marsupial. So if you expand on the definition, it's specifying that is a subclass of, as we can see, of marsupials. And we see that a koala is a subclass of something that's not hardworking. I don't know if koalas are lazy, but anyway, they're using it to say that koalas are animals. It's a subclass of marsupials that are not hardworking, or for the property hardworking, they have a value false. So that defines a koala.
Okay, good.
Now, what's interesting is that if we go to the properties definition, data properties, we're going to see that being hardworking is a property that applies to people, to persons, which makes sense, right? So it doesn't make so if you say that a koala is a marsupial that's not hardworking, by saying that it's not hardworking, you're saying that implicitly it's a person. So that's the way ontologies work, right? So you're kind of deriving the fact that in this case that a koala is also a person. And where's the problem? Well, the problem is that when you define a person, you specify that it's disjoint with marsupials, so there cannot be overlap. So what happens? So we've defined something, a koala, which is supposed to be disjoint with persons, but is also a person because it's lazy, because it's non-hardworking, right? Well, anyway, so I try to kind of tell the story, but this of course, the only way to surface that is to run some reasoning, and you can do that in Protégé. So you can start reasoning. I pick Pellet, which is one that I've used in the past. So we start the reasoning, and it's going to immediately, you see, mark in red the problematic ones.
Mm-hmm.
And there's other problems, but it will tell you, hey, these and the way of saying that is that a subcategory of nothing, which is a way of saying that you cannot, the moment you instantiate that, this would be a broken data set. So anyway, this can be done. This is for cases where you kind of build some of the more advanced constructs that languages like OWL offers you. In my experience, in our experience, that's not always the case. So people tend to stay in the definition level with some more basic axioms. But if that's something that you're using, the natural way to detect these type of problems would be using a reasoning engine. So I think with that we've covered the 4 blocks. So just to summarize, in the interest of time, we looked at structural metrics that looked at things like the connectivity, the overlap, how related were classes to each other, other orphan classes, things like that. How well does the ontology match the requirements? Is there a good coverage of the competency questions? What about the pragmatic ones? Is it well documented? Is it public? Is it accessible? Is it findable? And finally, the logical soundness that we did through the inferencing engine in Protégé. So that was it. I hope that gives an idea of different ways in which we can measure the quality of our ontology, and I hope to see people looking at those and maybe getting back to us with some questions or ideas or improvements to the things that we've created today.
Yeah,
so that's what we have.
That would be cool. Thank you very much, Jesus. I'd like to quickly do, because I know we have almost run out of time, but maybe we can squeeze in a question or two, because it came into through chat. Nuggets asks how ontologies can affect agents' work or performance. I think we discussed this in a couple of episodes in the past, maybe not particularly today, but I would say if you look back into the catalog of previous episodes, you should find a couple of episodes there where we discussed about ontologies and AI, particularly how the two work together and how you can improve AI work or AI and knowledge graphs with ontologies together. In those.
Probably the closest that I can think of is the ones around retrieval and how the information in the ontology drives the retrieval strategy. So my recommendation, go to our GitHub repository. You will have the whole catalog of episodes, and look at the ones that are annotated with ontologies. There will be some relevant, I mean, maybe there's many of them, but the ones that are annotated with ontologies and LLMs. And like this, you will find examples of how these two work together and improve the quality of the results.
Definitely. And then there was another question/comment that sparked a little conversation in chat, initiated by Eckhart. Eckhart says, curious how others create their ontologies. Ours started from a mental model. It was developed on paper, and before we digitized it, we applied it and refined it for years. It turned out to be a good data model and a basis for our ontology. I assume that there are many experts with subject matter knowledge who could turn their knowledge into an ontology. Yeah, I think that's what we often see. I mean, there are some generic purpose ontologies that work well, but then everybody has their own little domain, their own little use case. Little, or don't mean little in any meaning way, but you have a specific solution you want to drive and a specific pain point here you want to solve, and then you find a generic ontology that helps you a little bit, but then you have to narrow it down towards the one you're using it, and so it's all built. I think we dreamed about this. Have an ontology knowledge graph, a marketplace of all these concepts and things floating around. So it would be great. Yeah, I mean, the more people who are working with knowledge graphs and ontologies, the more people who make it available. I think that's one of the metrics you showed. The easier it is for others to implement, the easier it is for collaborations there. Yeah.
Yeah, absolutely. And there's loads of, again, literature about methodologies, best practices. But it's all about, the combination of extracting from the brains of the experts the bits of information and formalizing it in the right way, aligning it with the tasks that you want to solve. So, but yeah, there's I think in some of the documents the papers that we've shared today, you will find pointers to some methodologies that can be useful for you. So maybe that's a point to start as well.
Yep. Super. That leaves me with the usual. Obviously, I mean, I mentioned at the beginning, Notes AI is happening in April, so a couple of papers has unfortunately closed. But if you have something, send it to me now, and we'll try to make it happen. Otherwise, you can register for it and attend sessions in April. And yeah, if you want to know more about Neo4j and where to get started and how to build your ontology with a knowledge graph, then check out the Graph Academy to learn. Check out Aura, which Jesus showed today, or our developer pages, which have been just before the end of the year. We just updated them. They are coming, the new flavor. Lots of content has been updated and improved. So check out our pages there. And yeah, I think with that, thank you all for watching. Leave you. Hopefully, this was a good start into 2026 for all of you. I surely enjoyed it. And yeah, like Jesus said, we'll see you. We'll see you in the next month. Until then, yeah, take care and have a good start into 2026. Sorry, you were saying anything, Jesus? I was missing it.
No.
Yeah. Okay.
Just
All right.
see everyone next month. So yeah, that was I enjoyed the session. I hope that was useful to people. So looking forward to contributions and ideas for future ones.
Oh yeah, definitely. Always have send us your contributions, your feedback and comment. That's always great to see. And if you have any built anything with what we did, it's always nice to see that as well. To hear what you're doing there with the content we provide as a starting point. All right. Well then, thank you, Jesus, again for this today, for being here and for showing us the metrics for ontology quality. And yeah, take care, everybody. See you soon. Until next time. Bye.
Cheers. Bye-bye.